All right, so let's go ahead and see what we've got. We're going to take another little look at the ambiguous case, and instead of just trying to explain it, I wanted to just go ahead and do a couple of examples. They aren't quick. I will admit they're a little bit longer kind of problems because we have a little of work to do on those, but let's see how it works. Hopefully it won't be too bad. So the first thing I want to remind you is that when we have these stories like this, the ambiguous case, notice we have some angle followed by a side and a side. And this is how I usually choose to orient my pictures, but it wouldn't matter if you had them sitting in a different way. Like say this is 7, this is 8 units, and this angle down here is 45 degrees. That is also angle side side and kind of oriented in a different way. And that's perfectly fine. I just visualize things a little bit better this way. Now, in the previous video, what we talked about is how if we have this angle right here, and it's a known value, and again, I don't really want to write that in, but let's just say A is something I know. This side over here, again, is something I know. I'll maybe make it blue so I can distinguish between the two of them. That's something I know is equal to the sine of something that I don't know. That's this angle over here divided by, again, a side right here that I know. So all of these things are true statements. Now, when we dealt with this last time in the previous video, which really, if you haven't watched that, it's going to make it hard for you to understand this particular one. What we discovered is that if this angle is x, then this possible secondary triangle, I'm going to call it number 2, this angle right here that is across from that green one. Remember, this green angle right here is this green one right here. The blue one is the blue one, like this. This is the stuff we know. As it turns out, if there is a second triangle, which is a question mark, is going to be 180 minus x, because as it turns out, if you take the sine of any number, and it doesn't matter what that number is, again, the sine of, say, 27 degrees is some weird little decimal, not a very pleasant one. It is the same as the sine of 180 minus 27 with the exact same value. So keep in mind 180 minus 27 to be, I believe, 153. And notice we get exactly the same number, right? So it doesn't matter. As long as the two angles are supplementary, they work. So when you set this one up, the sine of this one and the sine of this one are going to be the same because they are, again, supplements. So we'll take a look at the quick ambiguous case. And so this is, to me, the worst story possible is when they don't give you a picture, they just say, go for it. So again, I personally, if we only have one angle, I'm immediately suspicious that it's going to be one of these problems. It's difficult. I usually like to make the angle at the bottom left. So here is a 74-degree angle, that's B. The side across from B, because this is B, the side across from it's going to be 15. And for me, this is how I choose, is I like to make this one C. So it goes angle, side, side. That's just how I visualize these problems the best. Now, there's a quick story that I have for you. This is longer than that. So it's just too long. You can't fit this in here tighter. But let's just say, for the sake of argument, you're not realizing the fact that I already know this can't work. Well, there's a bunch of reasons I could say this is true. First off, you should know that if we were to flip this one in, these are supplements. So whatever this angle is, if this one is acute, this one has to be obtuse. Well, that's a problem, because if this angle is 74 and it's opposite 15, this angle is larger, then this side has to be larger than 15, which it clearly is not. This is impossible. It's not possible. But there's a lot of ways that you can see that this triangle is going to work and this one fails. So that's just one of them. So I'm going to do it. Sine of 74 divided by 15 would be the sine of C over 12. I've done a few of these problems in these videos. Okay, so I'm going to multiply both sides by 12. Let's see what happens. So 12 times the sine of 74 divided by 15. I now have this thing sitting by itself, and I know that the sine of C is 0.769. I'm going to take the inverse sine of that thing, the inverse sine of that answer, and I got that this angle is 50.3 degrees. Now, of course, I could use that 50.3 degrees plus the 72. I could subtract from 180 and get that answer as 55. And you can see there's no mathematical problem with this. I could go through this process. I could do the law of sines one more time and say the sine of 55.7 over, I guess this is going to be little a, would be the sine of 74 over 15. See, there's no mathematical fallacy. This is a good problem right here. Check. That one's great. I've got everything I need. Now, I'm not going to take the time to solve for a right now, but I could. We've done that in other videos. Now look what happens when I try to solve this other triangle. 180 minus, let's see, 180 minus 50.3 is 129. We already said it was going to be obtuse. So I want to find out what that third angle is. Okay, so we're going to take 180, we're going to subtract 74, and we're going to subtract 129.7. And I found out that this angle is negative 23.7 degrees. But that doesn't make sense. You can't have a triangle with a negative angle. That triangle can't exist. But we already said it can't exist because the smaller angle must be opposite a smaller side. So there's no way that this big, crazy large angle, 129 degrees, it has to be bigger than 15, and it's not. So this is a bad triangle. So the first triangle existed, and the second triangle fails. So there was only one triangle to start with, and we could just reject all of this and say it can't exist. Now, going to the second problem, again, I've got this story where I got angle C right here is 27 degrees. That makes this side over here 7. That means I'm going to go ahead and make this one right here A, so this is 9. Now, this is the place that it's going to happen. This side is smaller than that one. So this is a problem where, in fact, I'm quite confident that this answer is going to have that second triangle. So we're going to set it up again that the sine of A over 9 is equal to the sine of 27 over 7. We're going to go ahead and multiply both sides by 9. And here we go. We're going to take 9 times the sine of 27 divided by 7. And I've got that the sine of A is 0.583. Okay. Now we're going to take the inverse sine of that, the second sine of that, and find out that that angle is 35.7 degrees. Well, that means if we took 180 minus that value, 35.7, I get 144. Now, that might trouble you a little bit because we had a big angle on that last problem, but let's see. 180 minus 27 minus 144.3 means this angle is a small angle, but it's a positive angle. There's no violation in this story. Over here, 180 minus 27 and minus 35.7. I got 117. These are two valid triangles, which means I can proceed further. I'm not going to do that in this video, but I could, again, solve by saying that the sine of 27 over 7 is equal to the sine of 117.3 over b. I could get this one and find this triangle. Over here, I could say the sine of 27 over 7 equals the sine of 8.7 over some other value b. And I could get this triangle, and in fact, that means there's two solutions, and they're both valid, and we would need to solve for both of them. And then my final example, number 3, is actually kind of my favorite, and it probably will be yours as well. is I gave you, again, the same idea that I've got an angle and a side across from it. Notice here I had an angle and a side across from it, an angle right here and a side across from it. I did that every single time. This is 42 degrees. The side across from it is going to be, let's see, if this is A, that makes this 15. If I make this one 35 and I made this one B, then I could say the sine of 42 over 15 equals the sine of B over 35. This is looking good. So I'm going to multiply both sides by 35 like we've done over and over again, getting rid of that number. So 35 times the sine of 42 divided by 15. Now I'm going to get a decimal, right? And I've got the sine of some decimal is 1.561. Uh-oh, we have a problem here. The inverse sine of that, my calculator is going to say, no, you can't do that. No solution. And the reason why is because when you look at this problem, the definition of a sine is opposite over hypotenuse. Since the hypotenuse has to be the longest side of any triangle, you cannot have a ratio where you have a little number over a big number and get a number bigger than 1. It's impossible. There is no triangle. So I'm not even going to bother to look for that second triangle because there's not even a triangle to find in the first place. So there is no such triangle. In other words, there is no solution. We can't solve it anyway, so we're going to walk away from that one. And so those are the three cases. Sometimes there's no triangle. Sometimes there's two triangles, but sometimes there's exactly one triangle. It just sort of depends. And really what it has to do with is as you work your way around, if the second side, the far side, is longer than the first side, there's only going to be one. It's just when the second side is shorter. And if you look at these two things, it is shorter. That's when something bad might happen where you might get two triangles or you might get none at all. All right. Hopefully that was good. We'll see you back in class. Bye-bye.